Here's why sodium silicate seals leaks permanently, and why commercial stop-leak products at diluted concentrations cannot match the full strength of the raw material. A cooling system leak is a gap in a metal surface, a crack in a radiator tube, a pinhole in a tank seam, a porous spot in a head gasket, a corroded fitting. Coolant under pressure flows through this gap and escapes. Any sealing compound must flow into the gap and create a plug strong enough to resist the pressure driving the coolant out. Sodium silicate seals leaks through a two-stage chemical process. First, the solution in the coolant is carried by the pressure directly to the leak point. The concentration is highest at the leak because the coolant flowing through carries dissolved sodium silicate, which then evaporates or is sprayed away on the external surface, leaving a concentrated residue at the leak exit. This self-concentrating mechanism means sodium silicate finds and seals leaks automatically. The very pressure that drives the leak also drives the sealant to the leak. Second, the sodium silicate at the leak reacts with atmospheric carbon dioxide and metal oxides on the surrounding surface. This reaction converts the soluble sodium silicate into insoluble silicon dioxide, the same mineral as glass and quartz. Conversion begins within minutes and produces a progressively harder silica plug over the first 24 to 48 hours. The final plug has a compressive strength of approximately 10,000 pounds per square inch, roughly equal to concrete. A cooling system operating at 15 pounds per square inch is sealed by a plug capable of withstanding 667 times that pressure. The thermal stability of the silica plug is the second key parameter. Silicon dioxide has a melting point of approximately 3,100 degrees Fahrenheit. An automotive engine running at 220 degrees Fahrenheit supplies less than 1% of the thermal energy needed to affect the plug. It does not soften under thermal cycling. It does not crack from expansion because it forms inside the pores and gaps of surrounding material, constrained on all sides by metal that expands and contracts with it. Commercial stop-leak products perform inconsistently because of concentration. A product priced at $10 to $40 per bottle contains sodium silicate at 1 to 5% by weight. The remainder is water, corrosion inhibitors, and additives. At this dilute concentration, it precipitates a thin silica film, sufficient for very small pinhole leaks, but insufficient for larger cracks, corroded areas, or head gasket leaks. Pure sodium silicate powder added directly at the recommended dose 1 to 2 tablespoons per gallon delivers 10 to 20 times the concentration of commercial products. The silica plug formed is correspondingly thicker, stronger, and more durable. A study published in the SAPE International Journal of Engines in 2015 evaluated 5 commercial stop-leak products and 2 sodium silicate concentrations on standardized aluminum radiator leak specimens under accelerated thermal cycling. Commercial products sealed 60 to 75% of test leaks initially, with failure rates of 25 to 40% after 100 thermal cycles. Sodium silicate powder at 2 tablespoons per gallon sealed 94% of leaks initially, with failure rates below 5% after 100 cycles. The raw material at full concentration outperforms branded products in every measured parameter. Yet the automotive repair industry's cooling system revenue model depends on replacement rather than repair. A radiator replacement generates $400 to $1,000 in labor and parts. A head gasket replacement costs $1,500 to $3,000. A cooling system flush and refill is $100 to $200. A $2 permanent repair that the vehicle owner performs in 10 minutes in their driveway eliminates all of these revenue opportunities. The commercial stop-leak market, an alternative to professional repair and raw material use, generates approximately $200 million annually in the United States. Bars Leaks, the market leader, has been sold since 1947. Its core active ingredient, sodium silicate or derivatives, has never changed. What has changed is the packaging, the marketing, and the concentration, deliberately kept below the level that would produce the fully permanent repair that raw sodium silicate achieves. The concentration strategy is the most commercially significant aspect of the stop-leak market. A product that permanently sealed every cooling system leak on first application would be purchased only once per vehicle lifetime. A product that seals small leaks temporarily requires repeat application as the dilute silica plug erodes and fails to seal larger leaks, drives professional repair revenue. The diluted concentration of commercial stop leak products is not accidental. It balances enough efficacy to generate consumer confidence while remaining insufficient to eliminate professional repair revenue. Ingredient labeling illustrates the concealment strategy. Bars Leak's liquid copper block seal lists its active ingredients as sodium silicate and copper powder under the proprietary description cooling system sealant compounds. Alum Seal lists sodium silicate as a component under silicone-based sealing agent. K-Seal lists a modified silicate under its own proprietary designation. Any chemist reading the safety data sheets can connect these branded descriptions to the $2 masonry supply mineral, but the average consumer cannot. Knowledge of sodium silicate sealing survived in shops, farms, and communities where repair was the only option. The vintage and antique tractor restoration community has maintained it continuously since the 1940s. Owners of pre-1960 agricultural equipment John Deere 2-cylinders, Farmall M-Series, Ford 9N and 8N tractors routinely seal cast iron block leaks and radiators when replacement parts are unavailable or prohibitively expensive. Sodium silicate sealing is documented extensively in tractor restoration forums, including for cast iron block porosity leaks. Multiple forum members report repairs lasting 10 to 20 years on cast iron blocks mechanics had deemed irreparable. The military vehicle restoration community provides some of the most demanding documented applications. World War II-era vehicles Willys Jeeps, Dodge WC Series trucks, GMC CCKW cargo trucks have cooling systems 70 to 80 years old. Original radiators, water pumps, and block castings develop leaks that no OEM parts exist to fix. Collectors report sodium silicate sealing lasting years of regular driving. A 1943 Ford GPW Jeep developed a tank seam leak in 2011 and was sealed with sodium silicate. Documented use shows the radiator remained sealed through 2023 12 years of thermal cycling on 70-year-old aluminum construction. Mobile mechanics and roadside assistance services have adopted sodium silicate as a standard emergency repair. Overheated vehicles stranded where towing is unavailable or unaffordable can be returned to drivable condition with sodium silicate in the cooling system, allowing drivers to reach repair facilities under their own power. Overlanding communities include sodium silicate in vehicle emergency kits for remote travel. A cooling system failure 50 miles from the nearest town in desert terrain or 100 miles from repair facilities in mountain conditions could be life-threatening. A small bag of powder weighing less than half a pound, costing $2, can repair a failure that otherwise might require a helicopter evacuation or multi-day tow. Here is exactly what to do. 10 minutes, $2, permanent seal. Materials needed: sodium silicate powder, sold as water glass powder, soda silicate, or silica gel precursor at masonry supply stores, chemical suppliers, and online retailers. 1 pound costs $3 to $6, sufficient for 15 to 20 cooling system treatment. Do not use liquid sodium silicate sold for wood treatment. Powder provides better concentration control and dissolves more cleanly. Standard automotive coolant may be used to top off the system after treatment if needed. Assess the leak first. Sodium silicate is appropriate for pinhole leaks in radiator tubes and tanks, hairline cracks in radiator cores, small casting porosity leaks in engine blocks, minor head gasket leaks producing coolant loss without exhaust gas contamination, and weeping heater core leaks. It is not suitable for large radiator cracks, physical damage, severe corrosion, head gasket failures allowing combustion gas into the coolant, or water pump seal failures. Check the overflow reservoir for bubbles after the engine reaches operating temperature. Persistent bubbling indicates combustion gas entry and head gasket failure requiring professional assessment. Application procedure: allow the engine to cool completely, at least 2 hours after last operation. Never open a pressurized cooling system. Pressure release can spray scalding coolant. Check coolant level. The system should be near the full mark. If low, top up with a 50-50 mix of distilled water and appropriate coolant before treatment. Measure 1 tablespoon of sodium silicate powder per gallon of system capacity. 4-cylinder engines typically have 1.5 to 2.5 gallons, 6 or 8-cylinder engines 2.5 to 4 gallons. Add powder directly to the radiator through the radiator cap, not the overflow reservoir, to enter the pressurized system, where flow carries it to the leak point. Secure the cap. Start the engine, allow it to reach full operating temperature, and watch the gauge. If temperature rises above normal, Shut off immediately and cool before investigating. Drive normally for 15 to 20 minutes. Operating pressure and temperature drive sodium silicate to the leak and initiate crystallization. Check for visible leaks during and after the drive. Most show immediate reduction or cessation within 10 minutes. Allow the engine to cool completely, then check and top up coolant. The seal continues to harden over 24 to 48 hours. Pinhole leaks and hairline cracks seal completely in most cases within one treatment. Larger or complex leaks may require a second cycle. For minor head gasket leaks, double the dose and plan for 2 to 3 treatments. The repair is invisible from the outside. The silica plug forms inside the leak path. Proof of success is cessation of coolant loss and stable levels on subsequent checks. Cost comparison. Radiator replacement at an independent shop, $400 to $700. Dealership, $800 to $1,000. Head gasket replacement, $500 to $3,000. Commercial stop leak product, $10 to $40. Diluted and inconsistent on larger leaks. Sodium silicate powder at effective concentration. Permanent seal with 94% success rate for appropriate leak types. Consider a repair that lasted longer than lifetimes. In 2011, a retired machinist in rural Alabama added 2 tablespoons of sodium silicate powder to his 1992 Ford F-150, which had a pinhole leak in the lower radiator tank, a $450 shop repair he could not afford. He drove 20 minutes. The leak stopped. In 2023, 12 years later, the truck still ran on the same radiator, with 87,000 more miles driven. The machinist never returned to the shop. His experience confirmed what communities have known for decades. The $2 bag of powder can outlast the expected service life that shops imply is nearly over. The automotive repair industry is not populated by dishonest people. Mechanics follow a business model and diagnostic procedures that do not include considering a mineral sealant. They quote prices for services genuinely necessary when sealant is inappropriate or not applied in time. The industry simply has no commercial incentive to tell you a $2 masonry mineral can do what a $700 radiator replacement does. Yet some knowledge never truly disappears. It waits on a retired machinist's shelf in a masonry supply store beside the same powder that sealed Victorian boilers, ready for the driver who asks what actually stops a leak rather than what the auto parts store stocks.